Okay, final rock group, Metamorphic Rocks. So once more, I will share my screen and then we'll do these pretty briefly now that we have a little bit more understanding about rocks in general. So remember that metamorphic rocks are these rocks that form in a solid state. So they don't melt and refreeze. That would be an igneous rock. They don't disseminate into tiny particles and then come back together. That would be a sedimentary rock. But they stay solid, and in the time that they're solid, they're exposed to heat and pressure in a way that they start to essentially get baked and squished, and they start to experience differences in the shapes of the bonds and the kinds of bonds that occur because of that heat and pressure. And so they metamorphose, they transform into a new kind of rock. So they change with heat, not enough to melt it, and pressure to form metamorphosed or new materials that may have completely different minerals than the original solid rock. So it's almost would seem like magic if you didn't have kind of the science to understand how these changes were taking place. So these metamorphic rocks form in a couple different environments. The two kind of most common ones are kind of contact environments, where usually this happens with magma that has intruded into what we call the country rock before, or the kind of surface rocks. And the magma has a lot of heat in it. That heat is transferred to some of the cooler rocks around the outside of the magma chamber, and then that heat is enough to actually transform some of the kinds of bonds and structures of the rock around them by baking them. And so we can have these metamorphic rocks that are just created because of this extreme heat environment, even though they don't end up getting hot enough to melt and just join the magma. So that's one environment. Another environment is called, or another kind of type of process is called regional metamorphism. And this usually happens along tectonic plate boundaries. So we'll talk more about those at a different time. But generally where we have different plates either colliding or subducting, where one is kind of sliding underneath the other, there's a lot of like heat due to the friction that's created there. There's just a lot of pressure there. And so over large regions along plate tectonic boundaries, so these regions might be like many hundreds of miles or thousands of miles long, we'll see these metamorphic rocks form. And usually what we'll see is that we have rocks of different types that form at different depths, where the heat and pressure environment along the plate boundary was a little bit different. So we have what we might call a higher grade metamorphic rock, a rock that has experienced a greater amount of change due to a greater pressure and temperature exposure, something like gneiss, which is shown down here in the bottom corner, confusingly spelled G-N-I-E-S-S. This is a rock that actually formed from like a shale or siltstone at the surface, and it looks nothing like that anymore as a result of these pretty severe chemical changes that have occurred inside the rock as it has been exposed to these high temperature and pressure environments. And then we might see things like schist, which is a different kind of metamorphic rock, or phyllite or slate. And so it's much easier when you see something like slate to imagine that it formed from a siltstone. It looks a lot like silt. Whereas it's harder to imagine that something like gneiss might have formed as from an original, what we call protolith of silt, the original rock that formed from it. But anyway, there's big bands or big regions in the environment that might contain these different kinds of metamorphic rocks because of the temperature and pressure exposures, usually along these plate boundaries. And then there's other kinds of things too, like dynamic metamorphism, where we might have surface areas along plate boundaries where there's a lot of rubbing but not a lot of increased heat, hydrothermal metamorphism, etc. But we're not going to get into all those right now. So some of the kind of characteristics of metamorphic rocks in general is a common characteristic that we call foliation. So if you think of something like slate that you might have seen before in some sort of like garden, or sometimes tiles and people's like bathrooms or kitchens are made from slate, they kind of have this layered look to them. And that layered look is caused because of the pressure. Those layers do not necessarily represent the original layers of sediment that originally formed slate, but they're formed as a certain directional pressure has been applied to those sediments. And kind of like if you had a bunch of like pickup sticks or something, if you had different fragments of sediment or minerals inside the sediment that were originally pointing lots of different ways, and then you kind of push them all together, they'll all start to line up and we get this classic foliated pattern. So rocks like slate are really easy to see that in, but then other rocks, even like these gneisses or schists, have this kind of banding pattern in them where there's kind of these repeated layers of kind of color or minerals that we can see, and that's referred to as foliation. However, some metamorphic rocks are not foliated. Things like marble, which is a metamorphic rock that forms from limestone, or quartzite, which is a metamorphic rock that forms from quartz-rich sandstone, tend to not really have a distinctive foliated pattern, and that's because of kind of the strength of the original mineral grains that are in those rocks, or mineral crystals that are in those rocks. They're just not really subject to being squished a lot, and then also they have kind of like a round or square shape to start out with, so they're not like linear, and they won't all end up lining up the same way to create that foliation. Okay, and then another concept that's important when we think about metamorphic rocks is metamorphic grade, which I already mentioned on the last page. So again, metamorphic grade kind of refers to how much the rock has changed from its original, what we call protolith, the original rock that it started out as. And so usually the increase in temperature and increase in pressure that something is exposed to is going to result in higher and higher metamorphic grades, which is going to result in the formation of different minerals, which is going to result in the formation of different rocks from those minerals. And so we already mentioned that things like gneiss are a higher grade metamorphic rock compared to things like slate. And then over here, this is a picture in Nepal, kind of high up in the mountains above the tree line. There's not a lot of wood resources there. So they have all these roofs that are built from slate rock that to form kind of like the tiles on the roof, or the shingles on the roof from this really foliated slate. So that's kind of interesting. Okay, I think there's a lot more we could talk about metamorphic rocks, but I think that's a good stopping point.